Good morning to everybody. So we are here today for discussing exciting new technology, SAT communication. And we are here with our partner and friends from Valeo that we're going to present more carefully later. So I will start with the presentation about SAT communication and what Qualcomm is doing in this space. And then we'll move to a panel session later on. So my name is Riccardo Calabro. I'm part of the European organization of Qualcomm. I'm responsible for the telematics connectivity business in Europe. Let's go to the slides. First of all, let's start who is Qualcomm. So Qualcomm is a company almost 40 years old, which started the work on the communication starting from CDMA world, then moved to 3G, 4G, 5G, and now also 6G. And we are basically investing in new technology from day one. And these are the areas that you can see on this slide where we are very active. So beside the mobile space, where basically most of the people will know us, we are very active in other areas like in the PC, like in XR and wearables and others. And between them also automotive, where actually I am active on. So Qualcomm is a company which is investing on new technology continuously. We have more than 100 billion cumulative R&D investment being made during the years. And you can see also the number of patents on different segments, not only mobile, which has been issued during these years. There are more than 160,000. So I think it's remarkable numbers for taking and having an idea about Qualcomm. So you can see in these slides the different areas and more in details, like beside the modem and the technology, communication technology where we have been investing. There are other areas like also the CPU. Everybody's aware of the Snapdragon, and this is a brand which basically is linked to our application processor and also our modem. And over time, we have been investing on other areas like in IoT and also now in compute and also AI. And this is where we basically have, let's say, our focus in these days. So basically today we are here to discussing SAT communication. And this slide presents you how basically a SAT communication system works. So first of all, Qualcomm is active in the automotive industry from probably 20 years now. And we have millions, hundreds of millions of cars on the world, which are running with Qualcomm modem. Qualcomm Wi-Fi Bluetooth connectivity, for instance, with infotainment and also with ADAS. So now, looking at the aspect for satellite communication, you can see basically that satellite communication is something you can use in different aspects. Let's start from what is available today, which is NB NTN, which constellation is already available. Ability to provide support for emergency services, like an emergency, an equal. One of the problems you have today is that in the moment there is an accident, the car is isolated somewhere, there is not terrestrial coverage, you will need to have a way to communicate that you had a crash, you had a vehicle breakdown, or whatever else happened, right? And that can be possible only in some areas where there is no terrestrial coverage via satellite communication. So, and that's what you basically do. On top of this, obviously, you can also provide messaging between, your car and someone else, receiving or sending transmission of the image of the accident, for instance, and as well as you can also some more let's say advanced use case like having remote access to your vehicle, or asset tracking for knowing where your vehicle is. You can see this slide. Basically, you have a satellite system which is connected to the vehicle, where there is a telematic box. Within the telematic box, there is a Qualcomm chipset. The telematic box was normally done by a tier one, like Valeo is close to us. And as well as then there will be obviously the partner for the satellite system and also for the gateway system. We're going to see in the next slide, which enables basically the messaging coming from the car, going to the satellites and going back to the Earth via gateway, which will be then basically used by the OEM or to others. So talking about specifically about SATCOM, about NB NTN, the message we want to provide today is this is a system which is already ready, right? Satellites are there. These are geo satellites. There are multiple constellations available. There is a company called Skyro, which provide the core, like the gateway for these satellites, then provide the information back to Earth. And these are launched. These already live is used. It is launched, and the smartphones. There are, I will not make names, but there are some public information about mobile phones which already launched NB-NTN. Therefore, is everything there available today? And Qualcomm is enabling this on the automotive industry as well. So here there is a list of partners we work with. So they normally work on specific bands. There are bands which are defined for, let's say, for satellite communication, like LS and band 23 bands. And these are basically, this is a system which is standardized, is using 3GPP release 17. And that's what we have on our devices, as we are working on the standard solution or proprietary solution, which will provide a solution also for the future, moving to broadband. Here we have a list of satellite constellation. You can see by yourself, let's say, where they're active, which are all, let's say, active and available today. So you go outside of this building, you're going to have satellites on top of you. You can make use it right away. So it's not something in the future, it's something now, which is available in our solution mobile phones and is also available in our automotive parts. In fact, we have customers which are working on it for launches in the next years with satellite communication. Here there is information about the bands because they're very important elements. There are some proprietary solutions which they struggle also to find a way to have band spectrum availability. In these cases, there is no issue because these are bands already selected for satellite communication and are widely globally available. Right? There are some regions of the world which will not use it. Some East, let's say, countries. But otherwise, the rest of the world, you can have it. This is basically a global solution, which is available today, and we're going to discuss the details today. So that's on my side. I will now start the panel conversation with our friend from Valeo, and we will go also on this slide while the discussion. So, David Roy.
Can you hear me? Yes.
Can you hear me? Okay.
Yes.
Fine. Okay.
So my name is David Rouanet. I work in Valeo. I work in the division developing the connected and the driving automation portfolio. And I work in the product strategy, and I am also the director of the connectivity strategy of Valeo. I am pleased to be there because it's a way to interact with the ecosystem, ITS ecosystem, and to discuss why satellite is seen as an important technology to be integrated in the automotive industry, why automotive is active to endorse this new technology.
Thank you for your presence and your support for this session today. So what we want to discuss today is to understand what is the current status of satellite communication, in particular in the automotive industry. And let's start from the, let's say, fundamental question: why we need it? Why we need it? What is the main reason, and what is triggering, let's say, the industry to look at this technology?
Some time ago, I was participating to a conference at GSM Association, and they were saying that on Earth, there is only 20% of coverage by the cellular. It means that today the cellular operators are investing on the population, how to cover the population, but not always where the car are circulating, where the truck are circulating. And what we want to provide is a good user experience, a peace of mind, where the user feels that they can use very well their services no matter where they are, and not where there is a cellular coverage. This is why we would like to see a complementary coverage between satellite and cellular to have the connected services with the same user experience. This is very important for us.
Totally agree. We have the same view. In fact, so if you start now looking at the global coverage of terrestrial network, this obviously it is wide, but it's still limited. So you will not have a global coverage everywhere with terrestrial network, right? Now, with the situation of operator expanding their coverage in area where maybe there is less population and maybe the investment is not, let's say, so ideal to invest in area where there are less people, but still valid for providing coverage, especially for emergency services. Satellite communication basically will provide the way to overcome this issue, right? And that's why we see the need to use this new technology, satellite communication, for enabling wider coverage, enabling services ubiquitous around, let's say, the world. Um, we have here the slide of 5GA. Maybe you want to also comment this.
Yes. So before commenting this slide, I wanted to explain the context. I don't think one company can make it possible to have satellite connectivity in the car alone. So we have decided to collaborate as a global ecosystem. So there is some big ecosystem like Fabio Automotive Association where we put this work item as a key discussion. How can we, telecom operator, automotive player, satellite operator, works together to make it possible in an economical way? And one of the communication tools is to build a joint roadmap. So this is why 5GA, with the contribution of satellite operator, automotive, cellular, we made this kind of roadmap. It's not a committed roadmap, but it gives you the maturity of the market. And today, as Ricardo was explaining, the geo constellation, so Skylo constellation as an example, is unable to send basic messages between the smartphone, the car with the satellite. And it is already very important because we can do already a lot of services with basic connectivity. So the first is clearly the emergency equal services. In case of crash, I can at least send a message to the center. But there is also, how can we also manage traffic management in very difficult condition? We also need to be aware of some danger on the car, like situation awareness and hazard, local hazard. It is very small message, so we can send this kind of message by satellite. So even if you are out of cellular coverage, you can be informed of potential danger on the road. And what is also going to come in the automotive is a digital key. So we can use our smartphone to open and close the car. And for this, we need to have an exchange between the cloud and the vehicle. And if we don't have this basic connectivity, we are not capable to use these services. We can also monitor the battery status. So I can do a big list like this, where a basic connectivity is good. But what is important is to have this global connectivity. So this is the first generation of services that can be already launched right now. And we are preparing the next generation of services based on the technology new radio NTN. For this, we need to build LEO constellation. So this is really new constellation under construction. It will reduce the latency time. So typically 30 to 40 millimeter is the target. We also try to reach the megabit, I would say, throughput to do some streaming application. So this will enable a new generation of services. What is still very unclear is the broadband connectivity. This is due to the cost of the technology, but the industry is working to reduce the antenna, to reduce the power consumption. So it's a question of time. We want to go step by step with a business model in mind and not rush and then discover that it's simply too expensive and there is no business. So we work collectively, Qualcomm, Valeo, all the ecosystem, to move step by step with use cases, business model, and the right technology.
Yeah, you're actually addressing the second question, which is what are the challenges to get these deployed, right? So, from Qualcomm perspective, we see, let's say, from constellation perspective, the geo-based satellites for NB NTN are there, right? So service available, and you can make use of it. Now, from the terminal perspective and from the, let's say, players which need to enable this, like mobile phone, let's say OEMs or car OEMs. So is it now the question to make this available, and the technology, as I said, is already available on our chipset. So the challenges are, let's say, more for the next generation. For the current generation, I think it is a matter of the decision, right? You want to enable it, you can enable it. So in terms of the future, once you move to NR NTN, we are talking about 3GPP release 18. This is something which will be more complicated because of the constellation which is not yet there. So we expect, let's say, that this will come soon, and there are multiple companies working on it, trying to, let's say, create the constellation needed for the commercial global services, right? And this will be, let's say, later on. So obviously there is some let's say challenges are linked to the investment for this, which will also link it to the business model, because once you enable this, you're gonna enable the wideband, let's say, satellite communication instead of narrow band as NBNTN is today, and this will obviously enable new services, which will help to justify also your cost. So that's the part where we see more challenges. But please go ahead.
So what is very important is to launch this service with a good economical model. So in the car today, you have the cellular modem, and satellite is an additional feature of the cellular chipset. So you're not going to use an additional chipset, new antenna. So for narrowband NTN, for new radio NTN, for geo constellation, it's the same technology, just software update. Same antenna, same 5G antenna. So this is very important because at the end, you're going to reuse the investment done on the smartphone. So I see that there is a lot of similitude between automotive and smartphone. For satellite, we are going to reuse exactly the same technology, the same constellation. So the smartphone is going to generate the volume, and the automotive is going to benefit from this smartphone volume to integrate this technology in our car. So for broadband, it is another story, but for the two first technology, this is obvious that smartphone and automotive will work together on the same chipset, on the same constellation.
Yes, and in terms of timelines, right? We will need to see now this deployment happening. So Qualcomm perspective is pretty clear, right? So NBNTN is there, and also in the automotive industry, we have customers which are currently working on it, because they, as just David said, you talk about enabling a feature on something which is a telematic box you have in the car, which you already have, right? You already have this in the box. So this is an extra feature which we are enabling. Therefore, there are customers which are working on this already now. So in terms of timeline of launches, we expect that these launches will happen in the next few years. Let's say before the end of the decade, we're gonna see some launches, while the NRNTN will come a bit later, obviously because of the constellation perspective. What's your view in terms of timeline?
I'm fully aligned with you. I think, as you said, for automotive application, we are talking about 2026, I would say, for the truck market, and the first narrowband NTN constellation are expected more for 2028 globally. And adoption by automotive on broadband is, I don't have yet date to communicate.
Yes.
It's too speculation right now. let's do let's do already what we can do as a maximum for the two constellation. I think it covers most of the use cases, the need from automotive industry.
Yes, we see also the car OEMs itself, right? So they look at the solution for ubiquitous coverage for enabling emergency services. Let's say, talking about Europe specifically, right? You have the eCall. eCall is also not coming to China, by the way, right? They also have the requirements. There are some other regions in the world where they are implementing this. So eCall is, let's say, the key let's say requirement, I would say, to trigger the need, because once you have this enabled in your cars, like here in Europe, you have it in each car you buy new, you can now enable these services also in area where there was no equal support because there was no coverage, and that's even if the terrestrial coverage is good, but still you will not be able to cover every place, and therefore this will help you. So therefore, from the car as well as trucks OEM business, we see the interest, and we see, let's say, on the car is, let's say, emergency call, then also the use case I was mentioning before with some, let's say, more advanced, as you know, even turn-by-turn navigation has been mentioned to us as a possibility. So you are somewhere where there is no network coverage, but you still get the this minimum information to do your navigation, right? Say on top of this, or add messaging and enabling, let's say, remote access to all these things which you can do. So then if you move to a truck OEM perspective, you know, here it plays also a good important role, also the introduction of autonomy, right? Actually, this is applicable also to car OEMs, but not only, right? Because the autonomy will create much more communication between the vehicle and the back end. And, you know, we have a scenario where, you know, autonomous trucks going, right? And you need to ensure that there is a back end receiving data continuously. And there is even the scenario where some customers, they look for have even more modems in their vehicles. It can be car, it can be trucks, in order to enable, let's say, wider, let's say, coverage in terms of, you know, having a support from one operator or another operator, and plus also SAT communication
Yeah.
to combine this and provide more ubiquitous services.
So personally, I would like to insist on the geopolitics of satellite. There is no one satellite constellation for all the region. As you know, China is investing on their own constellation, US their own constellation, and Europe is starting to consider now the IRIS² is the first constellation, not for automotive, but there is an initiative right now to also cover Europe. And each region has their own specificity in terms of spectrum, in terms of, I would say, application. And so it's really by working with each region that we will progress on this integration of this technology.
Yes, and so if you look at the use case perspective, right, and leaving aside the emergency call, right?
Yeah.
So where else you think, you know, Valeo see this becoming, let's say, SATCOM needed?
Right. So Valeo, we are not only a hardware technology provider, we are providing more and more software. We are also developing some connected services. We demonstrated some services on the gaming. How can we use the technology of the car for improving, for having an immersive gaming experience? How we can increase the safety with our technology. For this, we need to have connection with the backend. The services are more linked to the video. So obviously today, value services will be more leveraged by wideband satellite connectivity, clearly. The LEO constellation, we will need to have more, a lower latency, more network capacity, but we're also developing the digital key. We also want to improve the safety by sharing the V2X messages between the vehicle and the road infrastructure to inform in advance the driver of potential risk. So we want to contribute to increase the safety and to use the value services in a seamless spirit. I would say cellular satellite, I have the same experience. And just to conclude on the importance of one use case, for me, it's the digital assistance. So you interact more and more with your car by the voice. So you have a strong interaction with the cloud, but if you don't have this cellular coverage, you cannot use it. And by satellite, you will be capable to use it. So it is, I think it is one of the key use cases that will come with satellite.
So you, as a Valeo, you are also a very important player in the autonomous driving
Yes.
perspective. Maybe you can spend some words about the link between this and satellite communication in your own, let's say, planning.
Yes, so autonomous driving is not just the vehicle to drive itself. It's also what the user are going to do inside this autonomous vehicle. So it's a kind of entertainment. So for sure, if we have a broadband, I think the broadband connectivity will address autonomous driving use cases. I would say so the HD map can be regularly updated.
Right.
We can have a very frequent interaction between the vehicle and the road infrastructure. And inside the vehicle, we can also provide infotainment services and monitoring system. Teleoperation is a key use case for autonomous driving. We need to have broadband connection for this, I think.
Yes, you know, with the autonomous driving coming, as I said before, you have a higher interaction with the backend. And this, specifically in the initial phase, let's say not specifically, but I would say the initial phase of deployment is will be very interesting because there will be a lot of data back and forth. So once you have a car driving, you have also teleoperation, right? Aspect. And these are things which will need to have continuous connectivity available, right? So now starting from BNTN with the service available and moving to NRNTN, you know, you're gonna enable this everywhere, and you will not have a situation where you basically have lost the communication with the backend, where this information needs to come in a way for
Exactly.
for the complete assistance.
We need to have a video flow, uplink video flow for this kind of service everywhere. And the cost of a robotaxi is not the cost of a passenger car, so we can absorb the cost of the broadband connection for this.
Exactly. Yeah, robotaxi is a very good use case, right?
Yeah.
Where you have these autonomous driving already there available today, right? So that's will complement the support of connectivity outside of the city, wherever there is no network coverage, right? So,
We are aligned.
yeah. How do you see now? You know, there are some technologies which are proprietary coming.
Yeah.
So how do you see now proprietary vs standard, right? So, and then I will comment on this, what we believe.
So if you look at the situation in US, so you have IST Space Mobile, you have Starlink Generation 2, who are capable to have satellites. The satellite is playing the role of a base station. So you can use your smartphone or your car, have a direct connectivity between the satellite and the car without touching anything. And this is very attractive. Now we need to test in reality that it is working. Today it's a beginning. Let's see concretely on the field the reality. I think from a service point of view, this is very attractive. And if we look at in Europe, it will be a difficult story in Europe because we need to have spectrum sharing. Spectrum sharing means that we need to have an harmonization of the spectrum in the different countries in Europe, and very, very difficult. It will take a lot of time. So I think this scenario is not realistic in the coming years in Europe. And China, they can do it if they want. It's a decision from Chinese authority.
It's also different.
Yes.
They do their own, let's say, own solution.
But in the automotive industry, we have strong preference to go to the standard adoption, not to go to proprietary. Proprietary means that we are locked to the player. So we see a lot of satellite operator now very sensitive to the 3GPP standardization, much more active, much more eager to be active in this, to adopt the new standard. I think this is the right way to go.
We agree. In fact, our roadmap is based on standard GBP based solution, as our modem is, right? So moving from let's say release 15 to 16, I'm talking about 3GPP releases. 17 introduction NB NTN, NR NTN, or release 18. That's a progress, moving, enable one building block each time in something which is already existing, right? You are not reinventing everything, you are taking advantage of what is already there. So when you start about talking about proprietary solution, these are proprietary. These are solutions which are, let's say, linked to problems related to also the spectrum, as David mentioning. So here in the case of the GPP, is everything well defined, which bands, which will be then eventually made available for such, like for the case of NB NTN already there set up. So I would say that our view is that the industry has to go with standardization, and 3GPP is the right one. And we see this as a normal, let's say, requirements, basic requirements also for the auto industry. When we talk to car OEMs, one of the things we hear when there is new feature coming is always, we want to have something which is not only for us, we want to have something which is standard, which is used by others, is leveraged by others. It's not about, creating something which is only for, let's say, someone, and not scalable, very expensive. These are all aspects which obviously the car industry, the automotive industry look at, right? So it needs to have a wider deployment, utilized, and in our case, starting from mobile business is a perfect scenario. As happened for the introduction of the model in the car, is the same situation here.
So
go ahead.
when I started talking with satellite operator maybe 2-3 years ago, everybody was talking about proprietary solution. So I was coming from automotive standardization ecosystem. So it was two ecosystem to discuss how can we work together. And now we have seen progressively satellite operator much more open. And now they are a lot of them are now committed to 3GPP or open standard, which is very good. And the industry is working to work on the seamless handover between the satellite and the cellular. So a progressive implementation. So for this, we need to work with the network operator. So Ericsson, Nokia, Huawei. We need to work with the cellular chipset like Qualcomm for sure. The operator are there, and European Space Agency also took an initiative on this to put all the ecosystem together to work to develop the solution. So it's not just the ecosystem to keep together. There is the European Space Agency. You have a lot of initiative to put all this ecosystem working together to go faster.
Yeah.
And to reach the right technology for this. So this is very important.
Absolutely no. So if I look at telecom world, right? So operator perspective. So the limitation is linked to their coverage on the field, right? So in moving to 6G, there will be more, let's say, aggregation of, let's say, of new features, and satellite communication will be part of this game. And so also from their perspective, at some point we'll have also the way to leverage the existing constellation. They need to invest in constellation and provide to their customer a ubiquitous coverage, which they cannot offer by themselves, right? Because obviously they will have a limited coverage at some point, right? So that's how we see it. Now, if you look at the, let's say, hardware perspective, right? We provide a chipset, someone builds a module which goes in a box. the box is done by a partner like Valeo, right? So this is the process. Now we are providing the technology, they are the enabler of the technology, enabling this feature on modules where there is the chipset on it. And then there is the integrator and, the call it tier one, right? Which provides additional, let's say, content on it and put in the let's say provide this to the OEM. This is the setup, right? So we are starting from providing the technology, and there is the utilizer, which is the end customer, which is eventually that the who is buying the car. So the OEM is taking advantage of our, let's say, deployment in the mobile space, which is leveraging our automotive chipset roadmap, and it enables something which it is in the car in any case. You need to have a modem in the car in order to provide emergency support for emergency service, but also, as we all know, right, we all have a modem in the car also for providing internet to your infotainment system, to provide support for ADAS, autonomous driving to the back end. These are all elements. So what I'm trying to say is that we do leverage on what is there, right? We don't invent everything from scratch, but we take advantage of a box that in the car is in any case there already, right? You need to add one feature on top of it, which is a feature which we'll provide in our chipset, which will enable then to provide this satellite communication. And what maybe you can say what you are doing about this from, let's say, providing the TCU updated for
So
Satcom.
I would like to say that today there is a big so the architecture of the vehicle is under a full reconstruction with what we call the vehicle software, the SDV architecture, so software-defined vehicle architecture. So where the software has a strong importance, and we need to have a strong interaction with the cloud. So the quality of the connectivity is key for the success of the SDV architecture. And this is why I think telematics is very important, but also the capability to anticipate the quality of service or the cellular network to guarantee the quality of the connectivity, because at the end, we are going to put in place services that have a dependency with the connectivity. We are here. The connectivity is not just a pipe, a data pipe, stupid data pipe. It has to be an intelligent data pipe. So what is under development in the cellular has to be also put in place in the satellite connectivity, and why seamless handover is also very important to have, would say, to guarantee that we can switch from one to the another in a given time. So,
Absolutely. In fact, this is the other aspect I wanted to add is you need to add what they call it connected services, right? Which Qualcomm also provide, right? These are services which need connectivity, and connectivity is not everywhere available. That's why Satcom is going to provide ubiquitous coverage also for your services, right? Services which we are getting used to it once you have it in your car, right? So just a stupid example, right? You park somewhere in a big parking lot, and you don't know anymore where is your car. And to do that, you have, you can find it by the position. If the car doesn't have connectivity, then will be impossible to find it, or difficult to find it, let's say.
exactly.
So that's an element where SAT communication will add another, let's say, another way to extend the coverage and have the possibility to support services which are currently already deployed and everybody wants to have.
I'm okay.
Okay, so I think we are more or less at the end of the session. Is open for we are open
There
for
is a
questions.
question or?
Hi, Jose Pereira, Frost and Sullivan. You mentioned before about this will be a software update to existing hardware.
Yeah.
Do you envisage OEMs effectively fitting their chips that enable this sort of the software later, or does this have to be predefined in a hardware selection stage?
So the new architecture is defined so that we can update the software of the vehicle for for a lot of calculator. Yes, you have less and less calculator. You have very concentrated high processing unit element in the car that you can where you can update the software. The critical point is you must succeed to update the software, and you must do it in a very secure way. And satellite is a way to increase the cyber security because you have just one connection between the satellite and the car. On the cellular, you have more backdoor. So if you have some critical communication, you can do it by satellite. But to come back to your initial question over the air, this is one of the most important use cases of the automotive industry right now. And the system is designed to be updated.
Yeah, maybe I can add on. Let's say that if you take a solution which is already deployed today and doesn't have SATCOM, right? There is a possibility that this device, I'm talking about, chips that has satellite communication enablement, right? But you still need to have some hardware, like enabling the bands on the RF front ends. You need to have obviously the antennas support. So we do leverage on the existing antennas, but still you need to have some tuning or so. So I would say a software update would be possible wherever there is a system which is hardware ready, right? Hardware ready will enable you to do an app software upgrade. Otherwise, will require some, let's say, limited hardware change, which still, needs to be done in order to enable it. Yeah.
And an automotive is not a smartphone. So if you update the software, you need to comply with the existing regulation,
Exactly.
certification. So it's not open bar. You update everything like this.
Yeah, exactly. So once you provide a software update, which includes new feature like this, you need to have a new certification, and because you do also some hardware change in your box, in the module and the box, so that's why will require the new certification. I would say you can prepare all this, and you even do the certification in advance, and maybe you enable later if you believe. Maybe in some low-end car lines you will want to enable, you enable on some others. So it's everything possible, but it's something you need to prepare in advance.
Okay, thank you. You listed the satellite constellations. It's feedback here. Inmarsat, etc., availabilities. And if you see the car is the business case is changing away from the driver experience of the driver to the passenger as a consumer, and user experience in level 4, level 5 will be very different. As you mentioned, what's the role of satellite constellations? You see a trend that car OEMs are building their own constellations like Geely or Tesla with Starlink, or do you see the capabilities of the existing constellations, OneWeb, Inmarsat, as you mentioned, Iridium, whatever, as a combination, to fill this gap for so many car manufacturers?
Yes, some OEM like Tesla and Geely, they are investing in their own constellation. I'm not sure Geely is investing just for them. It could be a Chinese constellation for automotive. Tesla, I'm not in the, I don't know what Elon Musk wants to do, but we expect that Tesla and Starlink will join together for sure. I think for the rest, it's a question of risk management, investment. So better to do it collectively, not just a constellation for automotive, a constellation for multiple applications, smartphone, automotive, IoT. It's too dangerous to target one constellation for one specific ecosystem. And because the risk is very high to go to a proprietary solution for for automotive or smartphone, I think they all want to move to, or many wants to move to 3GPP standard to benefit from the economy of scale and to share the risk and to create a good dynamic between the technology and the services. I see more this trend.
I would say that's a specific case, the one you mentioned for this car OEM. Not everybody is invested in a separate constellation.
it's an
This is
exception,
a
it's an
big
exception.
investment, it's a different business.
It's an exception.
You know, I would say the OEM are looking for leveraging what is there and not building their own satellite. I would say that would be unlikely going to happen.
Yeah.
Okay. Thank you very much for your
Thank you
attention
for your
today.
participation. Yes.
Bye-bye.